In this lecture, we'll continue learning how to analyze Twitter data in Python. For 6 sessions, we will learn some basic data cleaning and filtering. We've used the pandas library, which is useful for data frame modification. Last time we have introduced the resources named Kaggle, and here we also have another resources to learn more by clicking this website. Let's do it. First, we import pandas SPD, and then we read our file locally. You need to change this to your local address. And we call this variable, let's see the result. This is our data file. In order to filter that, we just want to filter that by date. So we do not want the time step. So the first step, we change all of this to data time. And here we introduce another library called data time. From data time into data time. All the data stored in CSV is text file, is text data type. We change that to data time data type. And then we just want to select the date, this column .dt .date. That's it, the result. We only have the date here. And next step, we want to filter the data within a certain date range. We want to filter that is after 2019 January 1st. So this is our data frame. This is the condition. This column is greater than 2019 January 1st. And we just want to keep the 3 column create at text and screening. And we call this. We find some error. And the error is greater sign is not support between instance of data time and string. So why is that? Because after we do this, and the data has been converted to string data type by default. So we need to change that to data type again. By uncomment this, run that again, and run this again. We can see our data has been filtered. The next step is data cleaning. Generally, data cleaning have several steps as follows. So data cleaning is just steps to get rid of the noises. So such as we get rid of the actual spaces, we do some spell check, we delete all the formatting, highlight errors, something like that. But in our scenario, we will learn how to clean the data by getting rid of punctuations, square brackets, uppercase, and other special symbol like at, and we're getting rid of the hyperlink and additional spaces. And if you want to view more punctuations as expression of emotions, such as question mark or the combination of a colon and bracket, we need to be careful to get rid of those. And here is our data cleaning function. We import RE and string to library. RE is regular expression, and string is also command used with regular expression. So generally we import this too. And we define our cleaning text function, and text is input variable colon. Under this is our content of our function. First, we change all the stuff to lowercase. As second, we remove. So re.sub means we remove the first stuff we replace the first stuff with the second stuff, and this is the data source. So here, R denotes the regular expression. We replace this, the hyperlink, to spaces, and text is our data source. And here we also replace the bracket, replace HTTPS, punctuations, all the numbers, quotation marks, new line switching, CO, and RT means retweet. All of this will replace this thing to space, so we have many additional space. And the last line, we will remove all additional spaces and return this. Let's say our output. So we define this function and we run it in here. So because our Twitter data file is stored in data frame, so we need to go through to clean our data from the first row to the last row. So for I in range 0 to length of the data frame, first row to last row, and we call the first element. So here 1 means the second column, first column, second column, 0, 1. So we start from the first cell, we put that to the text variable and perform our cleaning. We call this function, and then we put it back to the data frame, and we do the loop, and we call this let's see the result. Okay, so it's pretty nice. However, we are compared with this, we see some words like COVID-19. If we want to detect it, we do not want to delete those. But in our clean data, we see we miss those. The reason is we change all of those to lowercase, and we also get rid of the numbers. So we just do simple modification to our clean function, and we feed the data again, and run this function again, and run the loop again. Let's say COVID is kept, but 19 is missing because we remove all the numbers in this line. So you can also do some modification to make that looks perfect. But right here, if you just want to detect these words, we can just detect this, the 5 letters, so that is enough. We can detect this to know how many COVID-19 appears in the whole piece, whole text. And here we'll also introduce some sentiment analysis, and we use the library called TextBob. TextBob is a Python library. It offers a simple API to access to the methods and perform basic natural language processing tasks. And there are many functionalities of TextBob. Below we introduce 2 of it. So first is polarity. It's a float, it's a decimal, slicing -1 to +1. So which means greater than 0 means positive statement, and smaller than 0 means negative statement. And we also have subjectivity. It's a decimal, it's a float, which lies in the range of 0 to 1. So this will refer to personal opinions, emotion, or judgment. And we want to use this to see whether the tweet data, the text data is factual information or too much subjective. And let's say first we run all of this, the library here, and we define those functions. The first function is get subjectivity, an input variable. We just return those things. TextBob input variable dot sentiment dot subjectivity. So this has already been written by others. We can just use it directly because we have import this library, so we can use this directly. And we also do get polarity, return this. After we define these two functions, we will apply this function to our text data. We add two new columns named subjectivity and plurality, and apply this and see the result. Here we get two new columns, and we can see the numbers here. So here we just get a score. So that is not obvious. We want to do more obvious work by changing the score to some label, some text. So if the polarity score is more than 0, we name it negative. Equal to 0, we name it neutral, otherwise positive. And we apply this function to the polarity column, and we see the data frame, and we can see this is a new column analysis. We see the three different type of message. So actually the technique is we detect in the text box we have a large volume of words which is categorized by negative, positive, and neutral. And in this whole step, we'll detect how many words appears, and based on that words, we will define whether that is positive and negative or neutral. And we also can print all the positive tweets by run this code. Now here I just run the first 50 rows. You can also replace by using this to run all of the data. Let's just say. I want to specify print here, string j plus bracket. This is the number, and the bracket is just bracket here. And print bracket here means I want to more space between the first line and the second line. We also can do the same thing to negative tweets. And we also can plot the polarity and subjectivity using scalar plot. We will import matplot as PLT. So this is a new library. We use that to plot something. And this is the figure size. And we do this and title X label, Y label. Let's see the result. It will take some time because they are large volume of data. We're waiting the start change to number. Okay, so here is the plot. We can see most of them, we pay attention to the polarity, most of them in the right side of 0, which means most of the data is positive. Also, we see the subjectivity is from 0 to 1. Most of them is under 0.5, which means most of them are less subjective. Is factual information. We also can get the percentage of positive and negative twists by doing some simple calculation. So this is, we collect all the data, all the twists, which is positive, and this is all the twists, which is use pt twists.shape. So this is the number of positive twists. This is the number of the whole twist, 1. Now here we times 100. Let's see. So this is 55% is positive. So negative 77%. We also can plot and visualize this by using plot title, X label, Y label, after analysis dot value dot count. So this is just the analysis column, which is this column. We count how many of the 3 label appears, and we get the bar chart. and plot.show will show this chart. So this is all the stuff for sentiment analysis.